Hi, welcome to my channel. In today's class, we'll be looking into partial fraction and resolution into partial fraction. Before we resolve into partial fraction, there are rules involving resolution into partial fraction. And the first rule says if the numerator of the given fraction must be of lower degree than the denominator of the fraction. If it is not, then we must divide through, or we must divide using the long division format. That is to say, if we have the numerator as 2x cubed plus 3x squared minus x plus 1 divided by x plus 1 and x plus 2. So if we are dividing this, we see that the numerator here, the degree of the numerator is greater than that of the denominator. So since they are greater, then we must, if the numerator is greater than that of the denominator, then we are going to divide the fraction using the long division format. The long division, we all know, involving the long division format we did in polynomial. So we are dividing this the dividend 3x squared minus x plus 1 divisor x plus 1 minus 2. So we find the quotient here. So now the quotient is what we are going to use and then resolve into partial fraction. So the first rule says the numerator of the partial fraction must be of lower degree than the denominator. If it is not, then resolve using the long division format and resolve it into partial fraction. That is the first rule. And the second rule says we are to factorize the denominator into its prime factor. You factorize the denominator into its prime factor to determine the shape of the partial fraction. So now, in order to determine the shape of the partial fraction, for example, if I'm giving this, let's say this is 2x plus 1 divided by x squared plus a plus 5x plus 2. So now this I can find its prime factor here. Look for factors, and when you multiply, you are going to have 2x squared, and when you add, you are going to have 5x. So just look for factors and then find its prime factor before you now start resolving into fraction. So this is the second rule. And then the third rule says, if you have a linear factor ax plus b, then the resolution into partial fraction of this will now be a all over ax plus b. That is a linear fraction or a linear factor of this form is given by a plus ax plus b is now given by a over ax plus b. And also a fraction or a factor or a linear equation of the form ax plus b all square is given by a over ax plus b plus b over ax plus b all square. So this is the third rule in resolution into partial fraction. And also a quadratic factors like this ax squared plus bx plus c equals to 0, or ax plus b plus c equals to 0 is given by ax plus b divided by the fraction, the quadratic equation ax squared plus bx plus c. So now, in order to resolve this into partial fraction, we are going to use this formula. So now let's look at an example to resolve into partial fraction. Suppose we are given 2x plus 3 all over x squared plus 5x plus 4. We are asked to resolve this into partial fraction. Resolve into partial fraction. So now, in order to resolve into partial fraction, remember the rules we said involving resolution into partial fraction. We said the first rule says the numerator must be of lower degree than the denominator. So now, if you look at the power of the numerator is 1 and the power of the denominator is 2. So therefore, the numerator is lower degree than that of the denominator. So it satisfies the first axiom. So now the second axiom says we can resolve into its prime factor. at the denominator, resolving to each prime factor, then before we resolve into partial fraction. So now this is a quadratic equation. I can solve this using factorization method. So now to find the prime factor of this quadratic equation, let's see. We are given this. We say we multiply the numerator, the first and the last value, so we have 4x squared. So now we look for two factors. Now when we multiply them, we're going to have this 4x squared, and when we add them, we're going to have the middle value of x. So when we add the same values, we have the middle number 5x. So now what are the factors? Now when we multiply, we have 4, and when we add, we have 1. So this is 1 and 4, right? 1 plus 4 is 5. 1 times 4 is 4. So we have x and 4x, x and 4x. So x times 4x will give us 4x squared. X plus 4x will give us 5x. So now the factors are x and 4x, right? So now instead of writing 5x, I can substitute these 2 digits. So therefore, this will now give us x plus 3 divided by, I have x squared instead of 5x, I write this 2 digit, x plus 4x, then plus 4. Then I can factorize these two numbers. You can factorize these two and factorize this. So what is common between these two is x. So I have x plus 1. If you remove x, you will be left with x plus 1 here. Also, we have plus. What is common between this and this is 4. If you remove x, 4 here, we will be left with x plus 1 also. So x plus 1 and x plus 1 are equal. So we take one of each, meaning we have either x plus 1 or x plus 4. So now these are the prime factors. These are the prime factors of resolution to this. So instead of writing this quadratic equation, I can substitute these prime factors here, and then before we resolve into the partial fraction. So we say therefore, the problem now is given by 2x plus 3 divided by, instead of the quadratic, I said I substituted by the prime factor, which is x plus 1 and x plus 4. So now I'm going to resolve this. Remember, the partial fraction says a linear equation of the form ax plus b is given by a over ax plus b, right? So now this is the linear equation. So now this can be written as a over the first value, which is x plus 1, plus b over the second value since they are both linear, which is x plus 4, right? So from here, I can multiply 2 by the LCM, which is x plus 1 and x plus 4. Multiply each time by this. If you multiply this time by the denominator will disappear, leaving this value, meaning we have 2x plus 3 is equal to. Multiply this fraction by the whole of this denominator. You will notice that this will cancel this, leaving this one. So I have a times this value now, x plus 4. Plus, multiply this fraction also by the LCM, which is this one. So this function will cancel this, leaving this one. Multiply by this one, I have b times x plus 1. So now I want to use cover of method. I want to cover b and find a. So to cover b, we must let this equation to be equal to 0. Therefore, to cover b, we say therefore let x plus 1 to be equal to 0. So it implies that x is equal to minus 1. So if x is minus 1, then therefore b is 0. So we substitute for x to be minus 1 in the whole of this equation. I have 2 times minus 1 plus 3 is equal to a times minus 1 plus 4 plus b times minus 1 plus 1. Minus 1 plus 1 is 0. 0 times b is 0. So minus 1 plus 4 is 3. 3 times a is 3a. Is equal to 2 times minus 1 is minus 2. Minus 2 plus 3 is 1. So therefore a is equal to 1 over 3. So we divide both sides by 3. So the value of a is 1 over 3. So if a is 1 over 3, I can also find b using cover method. I want to cover a now and find b. To cover a, we must let a to be 0. Therefore, let this function a plus 4, x plus 4. Also let x plus 4 be equal to 0. This implies that x is equal to minus 4. So when x is minus 4, we substitute for x to be minus 4 in the whole of this equation to find the corresponding value of b. So we say therefore, put x to be minus 4, we have 2 times minus 4 plus 3 is equal to a into minus 4 plus 4 plus b into minus 4 plus 1. Continue here. To simplify this, we say 2 times 4 is 8. We have minus 8 plus 3 is 5. We have minus 8 plus 3 is equal to, we have minus 4 plus 4 is 0. 0 times 8 is 0. So we left with plus b into minus 4 plus 1 is minus 3. Minus 3 times b, we have minus 3b. Right? And then minus 8 plus 3 is minus 5 is equal to minus 3. So we divide both sides by minus 3 by minus 3. This go with this, so b is equal to 5 over 3. This go with this. So b is 5 over 3. So we substitute the values of a and b in the equation. We say therefore 2x plus 3 over x plus 1 and then x plus 4 is given by the value of a, we said is 1 over 3. So let me write it here. We have 2x plus 3 all over x plus 1 and then x plus 4 is equal to a, we said is 1 over 3, divided by x plus 1, then plus the value of b is 5 over 3, divided by x plus 4. So this is the same thing as if you remove the division sign, this we are going to have 1 over 3 into x plus 1 plus remove the division sign here, we are going to be left with 5 over 3 into x plus 4. So now this is the resolution into the quotient fraction as given from the initial question. So if you have any question, you can drop it on the comment section. And if you are visiting the channel for the first time, you can give me like, subscribe, and give us a thumbs up.